Here we are on section 10.5, determinants and Cramer's rule. A determinant is a number associated with each square matrix. For a square matrix A, the determinant is commonly represented by the absolute values going around the A, or the shortcut DET of A. And we just take A times D minus B times C to get that determinant. You saw that earlier when we did the 2 by 2 where you had this AD minus BC to find the inverse. Well, this is the determinant that we're talking about here. So you've seen it, and we're going to be using it. And when we do it for higher orders, square matrices, we need to use a method involving cofactors and minors in the form of M of ij. Now this ij thing, the I is the row and the j is the column. So if we're looking for the minor 2, 1, that's row 2 and the column is 1. So that's what that 21, 22, 23 means. They're asking you to expand about the row and column placement. So we're talking about in this M21, before I get there, for orders of 4 or more, the iterative process will occur, and you break it up into 3 by 3s, and the 3 by 3s you break up into 2 by 2s, and that's kind of fun. So this means that in our 3 by 3, if I go with a 3 by 3, this is the first term. If I call this A11, first row, first column, that means we're adding those together and we get a positive. So we know that when we expand, we're going to be expanding it as plus, minus, plus, minus, plus, minus, plus, minus, plus. So when we do the first row expansion, it's going to be a positive, negative, positive when we do it. And I'm going to show you on this one right here. So we're going to be expanding about the second row right here. So we're going to be saying, we're going to be using those signs in front of the terms. So if I do that, I'm going to say M21, when we take this first row, or the second row, first column, if I cross those out, the matrix that I'm going to be using is what's left. So I'm going to put in there 4, 2, 8, 6. And when I do the cross products, 4 times 6 minus 8 times 2, I get a value of negative 8, or get a value of 8. But when we expand about this cofactor, we know we got to put a negative sign in front of it. So the answer has to be a negative 8. Let's do 2, 2. Now when I do row 2, column 2, my expansion, there's row 2, there's column 2. So it's not the same numbers that we're using. It's the ones that when you cross out the row 2 and column 2, it's what's left. So I'm going to make my little 2 by 2, 8, 2, negative 2, 6. And I know that because it's in this position, I'm going to say plus. So it's going to be positive of 8 times 6 is 48 minus negative 4, and I get a positive 52 there. When I do it up a little bit, when I do the cofat function expansion about the second row, third column, my cute little matrix C is going to be 8, 4, negative 2, 8. But remember, if we're expanding about this row, this third element's got to be a negative. So I'm going to say negative 64, 8 times 8, minus negative 8, which gives me positive 72 in there times the negative 1 gives me a negative 72. So when I add those 3 minors together, I get negative 28. Negative 28 would be the determinant of the whole matrix. Now, if I was to expand about the first row instead of the second row, should I get the same answers? Yes. It should get the same answers. Okay? Oh, we're not getting the determinant of the whole thing here because we'd have to multiply by coefficients. But we're just finding the small parts. And we'll talk about the coefficients in the next one. All right, so if I want to compute the determinant of this 3 by 3, I'm going to expand about the first row. And so I know my signs are going to be plus, minus, plus for these. And I'm going to expand about that first row. So I'm going to say 8 is my first. And the cute little matrice that I get left is this. Minus, because that middle number is got to be negative. And when I take and cross out that, I get, oops, it's a 4. Okay. And I've got to look at that number before I do it. So minus 4, 3, 3, negative 2, 6. And then plus, I don't have to cross it out. I think you guys see it now. 2 times 3, 9, negative 2, 8. And so to get my determinant of the whole thing, I have to go, there's an 8 there. I have 8 times the quantity of 54 minus 24, minus 4 times the quantity of 18 minus negative 6, plus 2 times the quantity of 24 minus negative 18. And so my determinant of this thing, 8 times 30, negative 4 times 24, plus, looks like 42 times 2. And if I simplify, I get 240 minus 96 plus 84. And that gives me the determinant of this matrix A, the determinant of A. So I would say DETA, or I could say A with the absolute value, that both same notation, is equal to 228. Okay? All right. So let's do one more. I'm going to do the expansion about the third row. So if we look at plus, minus, plus, minus, plus, minus, plus, minus, plus, right? They alternate. And so if I'm expanding about the last row, I'm going to have plus, minus, plus. And let me give you a hint. I'm not just picking the third row because I want to show something new. I'm picking the third row because there's a 0 in there, and 0 times anything makes it go away. So I'm picking it for my ease. So let's expand about the 4. If I go there and there, I get 2, negative 1, negative 1, 1. And then it would be minus 0 times, I'm not going to cross it out, I'm just going to fill it in. 0 times 1, negative 1, 2, 1, and then plus 2 times 1, 2, 2, negative 1. And so my expansion is going to be 4 times the quantity of 2 minus 1, and minus 0 times anything, I don't care what it is, plus 2 times negative 1 minus 4. And I end up with 4 plus 0 minus 10, which gives me a negative 6. And it's okay for it to be negative. So we would say that equals 6, or DET of A equals 6, negative 6. Now, this is a lot of fun to play with these things, but what's the usefulness of it? What are the properties of a determinant that helps us find stuff? If a row column is multiplied by a scalar, the determinant is also multiplied by that same scalar. Adding and subtracting row column from another row column does not change the determinant, so we can do them in either order. If two rows are interchanged, the determinant changes its sign from positive to negative and vice versa. And we can use Cramer's rule, which is kind of where we're headed to here. We know that if we take our determinant of the original, we'll get these D's down here. And if we do the determinant where we replace these values into the first row, you'll take that's the determinant with x. If you divide that by the determinant of the other, you'll get your x value for the whole thing. Same true with the y's. If you replace the y row with the answers and divide it by your original, you'll get that answer, and the same is true with the z's. So let's play with this a little bit and see if we can get one of those to work. We may not get this all done in 4 minutes, so I'm going to start a new video.